Does anybody remember? Mr. DeGeest? Distribute. Some people might have used the word foil in the past. Have anybody heard about foiling? Yes, I don't like to use the word foil because, like, it is just distributing. I like to keep things as simple as possible and not use many different words. So let's distribute. Now remember, if I have like 3 times x plus 2, we know that we like multiply the 3 by the x and the 3 by 2, and we say it's 3x plus 6, right? We're going to do that with our x's. X times x and x times 5. Now, Mr. Black, what is x times x? That's a great question. Like, what is x times x? Is it 2x? This is very, very important. X plus x is 2x. But x times x would be x squared. So I start with x times x and I get x squared. Then I get x times 5, that's 5x. Good. I'm done with distributing the x. Now let's take the 2 and distribute that. 2 times x would be 2 times x. 2 times 5 is 10. Right? Does this look familiar to most of us? Nod your heads so that I know you're with me. Now, what was one extra thing I could do instead of just leaving it as x squared plus 5x plus 2x plus 10? Ms. Reyes, what can I do? What can I do here? Could I simplify this more? Could I make it look different, or am I done? So the 5x and the 2x I can add together to get 7x. Beautiful. So this is what I'm trying to show you, is that something like this turns into something like that. And that is our goal today, is to start here and turn it that way. It's called factoring. It's like reverse distributing. And it will help us solve these quadratic equations that I brought up before we started this lesson. Okay? Now, let's do 2 more. Why don't you guys do this one, go ahead and distribute this one out and simplify it fully, and go ahead and distribute that one out and simplify it fully. Go ahead and check with your neighbors. What's up? All right, so question here, like, man, does this negative go with the x? Do I have negative 5x? What I love to do, Mr. Quinn, when I see subtraction symbols is what? Plus a negative. Like what kind of calculators? What do you need a calculator for?
Oh, I'm from Miss
Reyes. Miss Reyes. And you guys need some extra calculators. Yeah, here's some extra calculators. 3, 4. Just make sure they come back. Thank you. Okay. Turn that into plus a negative. That way you know, like, hey, just add everything together, but that's a negative 4. Okay? All right, let's go ahead and finish off that second one if you're not done with it yet. And don't do this last one yet. Don't do the last one yet. That's okay. We're gonna think about it anyways. So I got x times x, x squared, x times 5, 5x. Negative 4 times x, negative 4x. Negative 4 times 5, negative 20. And then 5x's plus negative 4x's is 1x. All right, now I'm going to pause. Because I like you guys, like to go straight to my answer if I can, as quickly as possible because I'm lazy. We all are a little bit inherently lazy. Do you see a way to go right from there to there, skipping here? Do you see a way to go from right there to there, skipping there? If you do, go from there to its simplified distributed form, skipping the middle. If you don't, check with your neighbors, see if they can help you. Go. Can you skip the middle and go straight from x plus 4 times x plus 3 to x squared plus 7x plus 12? Can you go from x minus 4 times x plus 5 straight to x squared plus x plus negative 20? Can you go straight from x minus 2 times x plus 3 to x squared plus something x plus something else? Good. Now, go the extra step, please, of simplifying this 3x and this 4x so that it's x squared plus 7x. Our goal is to be able to see that I can go straight here to there if I just kind of figure out what's going on. Here, this is x squared plus x minus 20. See if you can go straight from here to there. Remember, this is plus a negative. Okay? Now see if you can go straight from there to there. Good. What do we do? What can we do? Mr. Steck, what'd you do? How'd you get straight from x minus 2 times x plus 3 to an x squared plus something x plus something?
I don't know if it's right, but I kind of just put multiplied the two x's and the numbers, and then just kind of add it.
Okay, so what is the pattern that emerged?
I went x squared, the x is going to x squared.
Right.
And then I did basically just combine the negative 2 and 3 so you get 1.
Okay, so you added negative 2 and 3, good, and that gave you the middle.
Then I multiplied it.
And you multiplied the negative 2 and 3, and it gave you the last term, right? We notice minus 4 plus 5, 1. Well, it's that makes sense. 5x and negative 4x, I can combine those. Okay, so it's like I'm adding them together. Then minus 4 times 5, negative 20. These two numbers, if you add them together, gives you that middle term. These two numbers, if you multiply them together, gives you the last term. This, my friends, is the secret to going the other way, which is what we're going to do today. What we are going to do today is understand that this number right here was negative 2 plus 3. This number right here was negative 2 times 3. This number, negative 4 plus 5. This number, negative 4 times 5. This number, 4 plus 3. This number, 4 times 3. We are going to go backwards. Okay, because going backwards in factoring is actually going to help us tremendously solve an equation like this, which we will get to next, but I'm not going to focus on the answers to this question yet. All I'm going to do is say, hey, make this look like the product of two different x plus things. I'm not going to put anything on my paper besides the fact that I know there's two numbers that add to get 9 and multiply to get 14. If I can figure out those numbers, I can factor x squared plus 9x plus 14. See if you guys can do it yourselves. We'll get it.
Yeah.
I know. Very good. Okay, we notice 4 plus 3 is 7, 4 times 3, 12. Negative 4 plus 5, 1, negative 4 times 5. And like, boom, what we're now doing is going from here, there, from there, there, from here, there. No. You already had your chance. Ms. Chisholm, what are the numbers? 7 and 2 added together gives you 9. 7 and 2 multiplied together give you 14. We just factored. Now, there are other ways to get the same thing, but I feel like this makes sense to me. If you understand distribution, you should understand how going backwards, you're looking for two numbers that add to get this and multiply to get this, because we ended up adding 3x and 4x. We multiplied 3 and 4. We added 5x and negative 4x. We multiplied to get negative 20. We added negative 2x and 3x. We multiplied to get negative 6. Okay? Cool. So all we're going to be doing is understanding that x squared plus some amount of x's plus a number can look like this product of two different things. Knowing that this can look like a product of two different x plus things, all we need to find is the numbers that add to get your middle term and multiply to get your last term. Let's do the first two and check with your neighbors. No. Write it down as a factored form. We are taking what we call a trinomial, and we're turning it into the product of two binomials. Trinomial means it's got three things. Binomial means it's got two things. It's a product of two-thing guys. You were thinking about two numbers that add to get 10 and multiply to get 24. X plus, close off, X plus. All you need to do is find two numbers that add to get 10 and multiply to get 24. Nope. Do the next one, please. Now, put it the other way so we understand that you could distribute to go back here.
Okay.
Okay? Just like you did for this one and this one. I like that. Okay. Okay, now, if you are having difficulty, you can do yourself maybe a little bit of a favor. Take the third term and write down all of the different ways that you can multiply two numbers to get 24. I got 24 and 1. I got 12 and 2. I got 8 and 3. I got 6 and 4. Those are all the factors of 24 into two different terms. One of these sets, if I take the numbers and add them together, I get 10. What is it, Ms. Villamore? Yeah, 6 and 4. It doesn't have 5 anywhere because 5 times any number is not going to give you 24. Okay, so 12. I got 12 and 1, 6 and 2, 4 and 3. 4 and 3. Got it? Now, those are easy because we just had positives. But once we start incorporating negatives, it gets a little trickier. So we just got to use our brain. The two numbers need to add to get -2 and multiply to get -8. Nope. Add to get -2, multiply to get -8. Very good. Now I'm thinking with 8 that it's got to be not 8 and 1, but it's got to be 4 and 2. 4 times 2 gives me 8, right? But one of them's got to be negative, and one of them's got to be positive. It can't be flipped. It's only one answer. There's only one way, so that if I add them, I get -2, and I multiply them, I get -8. And that is ensuring that 4 is negative, 2 is positive. If I had +4 and -2, this would be in the positive 2x. That wouldn't have worked. Okay, do the next one. So again, this needed to be a -4, and this is a +2. So that -4 plus 2 is -2. -4 times 2, -8. What about 10 and 2? Now remember, it's this number, 20. The products to get 20. So 20 is either 20 and 1, 10 and 2, there's nothing in 3, there's 5 and 4. -10, +2. -10 plus +2 gives you -8. -10 times 2 is -20. Okay, do the next one. Now, these both had negatives. Now one of them is negative, one of them is positive. Just got to think. No, let's keep going. We had a restroom break time. Come on, what do we got? What two numbers add to get -10 but multiply to get +16? We should know that if you take two negatives and multiply them together, you'll get a positive. -8 and -2 will add to get -10. They will multiply to get +16. So if you see a positive, you can either have two positives, you could have two negatives. Ooh, 40. All right, let's see. Here are the options. 40 and 1, 20 and 2. Let's see, 3 doesn't work, 4 works, 10 and 4. Let's look at 5, 8 and 5. Okay. 6, no. 7, no. Okay, so that's it. Those are my 4 options. Which two can be combined so that when you add them together, you get 3. When you multiply them together, you get -40. Yes, 8 and 5 is correct, but which one's positive, which one's negative? Both negative? Yes. The 5 is negative. The 8 is positive. 8 plus -5 is +3. 8 times -5. What's that? What's this?
I just checked, man.
Nice. I like it. Mr. Quinn did something beautiful. He wasn't sure. What did he do? He went the other way. He distributed. He checked. He's like, okay, yep, x squared, -5x, 8x, -40. Boom. Those two combine to be positive 3. All right, let's keep going. We don't have much time, so we're going to go through the next couple really quick. We're going to rapid fire, starting with Mr. Sripata. 2 numbers that add to get -3 and multiply to get -4. Won't be 2. 2 and 2 won't add to get 3. 4 and 1. Which one's positive? Which one's negative? I got to get -3 when I add them. 4 is negative. Beautiful. Mr. Steck. X squared minus 12x plus 36. What do you got? 6 and 6 positive? One of them's negative, one of them's positive?
Oh, wait. No, both negative.
Both negative. Good. You got it. Ooh, that's a tricky one, Mr. Stein. What do you got? I got 36 and 1. I got 18 and 2. I got 12 and 3. Oh.
12 and 3.
Yeah.
12 and -3.
Yes. Excellent. Ms. Villamore, 2 numbers that add to get 2 and multiply to get -35. I'm going to give you some products of 35. 35 and 1. I don't have any 2. I don't have 3. I don't have 4. I got 7 and 5. That's it. Those are your 2 choices. Either a combination of 35 and 1 or 7 and 5. 7 and 5, and how are you going to combine them? Unbelievable. Very, very good job. Positive 7, -5. All right, Ms. Crabtree. X squared plus 10x plus 25. 5 and 5. You know what's great about yours, Ms. Crabtree and Mr. Stex? You can actually write this as x plus 5 squared. And you could have written yours, Mr. Steck, as x minus 6 squared. We're going to do that in the future on purpose because it'll help us. Okay? X squared plus 11x plus 10, Ms. Reyes. Finally, we get one where 10 and 1 or our number and 1 work. Okay? Good. What happens if there's no middle term? Well, you could, though you won't do it moving forward, but you could rewrite it so that there is a middle term. Plus 0x plus 1x would be completely different. Okay, well, it's still an x squared plus an x plus a number. It still can be written as x plus something times x plus something. You can figure out the numbers. What 2 numbers multiply to get -25 but add to get 0? -5 and 5. This is what we call a difference of squares, and we'll talk about this more. If you have a perfect value squared minus another value being squared, this is like x being squared, and this is 5 being squared. You'll have the positive number and the negative number. This is x plus 6, x minus 6. 6 squared is 36. X squared minus 4, x plus 2, x minus 2. Right? It's called a difference of squares. There's a rule for it that we'll get into later, but for right now, it's good. Now, you got to understand, sometimes you cannot factor. Cannot factor. X squared plus 9, there are no 2 numbers that add to get 0 and multiply to get 9. You might be thinking, oh, 3 and -3? But nope, you won't get 0. That doesn't work. 3 and 3? Well, you should get x squared plus 6x plus 9. That doesn't work. It's got to be set up in a very specific way so you can factor, okay? X squared plus 4, you cannot factor. Cannot factor. X squared plus 4x plus 10, cannot factor. You might be thinking x minus 4, x minus 1. Nope, that would give you positive 4, cannot factor. That's okay, but it's good to show some of these are not able to be done, okay? Now, what's going to happen in the future, and this is important, is that if I said this was equal to 0, you should be able to give me my answer really quickly. If I have x squared minus 3x minus 4 equals 0, and you said, you know what, Mr. Messler, that's the same as x plus negative 4 times x plus 1 equals 0. You should be able to say, oh, I know what values of x make this left side equal to 0. Who can give me one value? Mr. Butterberg, give me a value that I can plug in to x to make this side 0.
The left. Is there two different?
There are two. Just give me one.
Oh, okay, 4.
4. Positive 4. Let's see. 16 minus 12 minus 4. Okay, yeah, it got me 0. But what you were thinking was like, oh, 0 times whatever is 0. And if you plugged in 4, you got a 0. Does that make sense? Okay. So you, and this is what we're going to be doing next class, can say 4 would make this 0. Negative 1 will make this 0. You plugged it back into this. Since these are equivalent to each other, it would also be an answer to my first one. Isn't that really nice and easy? It's really nice and easy. This is how we're going to be able to solve this. It's not like a regular linear equation, 2x minus 5 equals 0. We have to do it this different way. And we can see we're going to have two intersections, and we found them at 4 and at negative 1. Here's the problem, though. We see not every single quadratic can be factored. This is where our other techniques that we are going to spend a lot of time on for the rest of the unit come into play. How can I solve this when I can't factor? Okay? All right, moving on though. We need to be able to factor things that are a little bit more difficult than just x squared plus 5x plus 6. This guy right here, 2x squared. I know right away this is not x plus something times x plus something. Am I right? Why not? Because I need to have 2x squared. And I know if I distribute this x to this x, I'm going to get x squared. And it's like, no, that's not it. I need 2x squared. All right. So this is why we're going to learn this other technique. It is not as easy as your first technique. Okay? So we need to practice. It is the technique that I think is the best one, but there are different techniques to even learn this. Okay? Now you guys remembered the two numbers that add to get 5 and multiply to get 6, right? 2 and 3. Watch what I'm going to do. I'm going to go backwards literally one step at a time. You know how we just like jumped straight from here to here? And then when we went backwards, we went straight from here to here. I could actually incorporate this middle step. Okay? So instead of saying x squared plus 7x plus 10, oh, that's just x plus 2 times x plus 5. I'm going to say, you know what? That's x squared plus 5x plus 2x plus 10. I'll show you why. Okay, here we go. We're going to throw in the middle step. The two numbers that add to get 5 and multiply to get 6 are 2 and 3. Two plus 3 is 5. 2 times 3 is 6. I'm going to write it as x squared plus 2x plus 3x plus 6, right? So it's like I threw in the middle step going backwards. All right, go ahead and write that down. Now watch what I can do. I can turn this into two sets of 2. And recall, if you have something like 2x plus 4, you could divide out what we call a common factor. Or if I had like x squared plus 2x, I could divide out an x to give me x plus 2, like backwards distributing. Do you guys remember that? It's been a while, and if you don't remember it, we'll get you back at it. You can decide, okay, both of these share an x. I'm going to factor out an x. You can decide both of these share a 3. I'm going to factor out a 3. Then you can see, oh, both of these share an x plus 2. I'm going to factor out the x plus 2. What I have left is x plus 3. Look at that. I went from there to there. Now, it's very, very unnecessary and tricky for this type of problem. You could have gone straight from x squared plus 5x plus 6 to x plus 2 times x plus 3. But for this one, it's extremely helpful when a is not 1. Let me show you the process. You ready? Because the first term is not just 1, I'm going to multiply the first term and the last term together. Go ahead, follow along with me. We're gonna be a little bit confused to start with, but then we're gonna figure it out. I get negative 30. You're going to find two numbers that multiply to get this a times c, but add to get the middle term b. Go ahead, copy it down, follow along. Who could tell me the two numbers that multiply to get negative 30 and add to get negative 7? Negative 10 and 3, okay? So we are going to rewrite your middle term using your two numbers. You're going to say this is no longer 2x squared minus 7x minus 15, but 2x squared plus negative 10x plus 3x minus 15. It doesn't matter what order it's in. Why it's a secant? Okay, so like sure, that's a secant, but you know that like past this point, that's underneath that, right?
Yeah.
Okay. Past that second point, your line is underneath your curve. Okay, then we will factor by grouping. Ready? Turn this into two sets of 2. Divide out the biggest possible thing you could divide out. I could divide 2x out of both of these terms. 2x out of 2x squared, I just have an x left over because 2x times x is 2x squared. 2x times negative 5, negative 10x. Okay, good. Over here, I can divide out 3. When I divide 3 out of 3x, I just have x left over. When I divide 3 out of negative 15, I have negative 5 left over. If you see the same thing, you're pretty much done. That goes on one side. Whatever was left over is factored out of the other side. It's different, but it involves the same kind of process. It's just a little bit more intense. In the grand scheme of things, it's actually not super important to be able to know how to do this process. Some of you might be able to just guess and say, well, I know I'm going to have 2x times x. I'm going to have versions of 15 and 1 or 5 and 3. Maybe you could figure out that it's going to be negative 5 and 3. It actually takes a lot more thought to do that than it is to go through this process. Okay? All right, here we go. Let's try. Multiply A and C. Write it down. Look at B. Write that down. What's A times C? 24. B is 11. Find two numbers that multiply to get A times C and add to get B. Mr. Charles, what two numbers multiply to get 24 and add to get 11? I'll give you options. 24 and 1, 12 and 2, 8 and 3, 6 and 4.
8 and 3.
8 and 3. Okay. Take the middle term, turn it into 8x and 3x. Doesn't matter the order in which you do it, but just for everybody to follow along with me, let's put 8x first and 3x second. Then, two groups of 2 factor out the greatest common factor. Out of 2x squared and 8x, they share a 2x. What's left over is x plus 4. Out of 3x and 12, they share 3. What's left over is x plus 4. Factor out the x plus 4, whatever's left, that's in the other term. Okay, if you think about it, like we are going literally step by step the backwards way. We could have said back here, this is x times x plus 5 and negative 4 times x plus 5. And then it's x squared plus 5x plus negative 4x plus negative 20. And then it's x squared plus x plus negative 20. Did we do this? No. But going backwards, it actually helps us sometimes. But going backwards sometimes doesn't make much sense. We're just going to have to practice. Okay? So, this one. Let's see if we can do this one. (5x squared minus 14x plus 8). Start by multiplying A and C together. And then writing down B. You are looking for two numbers that multiply to get that A times C and add to get the B. Eight times 5, 40. So I got 40 and negative 14. Negative 4 and negative 10. Take this middle term, write it as a sum of two different things, plus negative 10x plus 4x, negative 4x. Two groups of two, factor out the greatest common factor. Okay. Pause. Do we see x plus negative 2 and negative x plus 2? Are they the same? No. Since they're not the same, I can't do the next step. If this was a negative 4, however, it would be. Sometimes you need to adjust what you factor out so that you get the same thing, and that can be factored out. Don't pack up until I tell you to do so. Yeah.
I'm confused on how you got the negative 2. Like, I know how to do the first part, but then the second part.
What's 10 divided by 5?
Okay.
2. Okay? So we will have to practice factoring out greatest common factors because I feel like you guys are resisting. It's been a while since you've done it. Okay, hold on. You have homework. The key will be on your web page. The homework is the last 3 pages of this note packet. I will have the key available, but I'm collecting this, and if it's not 100% complete, you're not going to get 100% completion. Okay? I'm going to be posting the video as well of this lesson because I just recorded it. I'll skip this one, do this one. All right, that's good. Enough for these notes.